In this video, we're going to begin discussing ellipses. We're going to look at what the equation of an ellipse looks like and how to graph it. So we have two ellipses here. The equation is going to look really similar, but slightly different depending on whether it's long in the horizontal direction or whether it's longer in the vertical direction. And really the only difference is where is the location of A and B. So for both of these, A is the larger value, and so if the larger value is underneath X, then it's longer in the X direction, which is the horizontal direction. And if that larger number A is underneath the Y part, then it's longer in the vertical direction. So let's just talk about some of the things that we're going to see on the ellipse and the different parts that we're going to identify. So the ellipse is going to have a center. And then at each end of the long direction, we have what's called a vertex. So there's our center, there's a vertex there, and a vertex at the other end. Same thing over here. And then this segment here that I'm drawing in with a dashed line that goes through the center. I didn't draw that very well, but it goes through the center and it connects the two vertices. That line segment is called the major axis. And it's called the major axis because it's the longer direction. We also have a minor axis going in the short direction between this pair of points. Some books call these co-vertices. Our book doesn't really name them, but the segment that connects those points, so going through the center but in the short direction, that segment is called the minor axis, since it's the shorter one. And then a couple other key points of interest are going to be each of these is going to have a focus between the center and the vertex on that major axis, and we're going to have a focus at each end. So there's a focus here, for example, and another focus over here. Each focus is always on the major axis. So over here we're going to have a focus here and a focus here. The distance between the focus and the vertex is representative of how elongated the ellipse is. If it's more stretched out, more elongated, the focus will be very close to the vertex. If it's not super stretched out looking, if it's like close to almost looking like a circle, the major and minor axis are almost the same length, then that focus is going to be closer to the center. And the two are going to be the same distance from the center. So speaking of that, the center is going to be identified by hk. So in the equation we see x minus h and y minus k for both of these. The center is going to be at hk when we graph these on the coordinate plane. We already mentioned that a is greater than b, so look for where a is. The larger value is underneath x or y depending on which direction is longer, and that's because a is half the length of the major axis. So the major axis goes all the way from one vertex to the other. That value a is half of that length. So basically from the center to a vertex, that distance is a. And so that distance a is going to be horizontal if a is underneath x, and that distance a is going to be vertical if a is underneath y. And then that value b is half the length of the minor axis. So the minor axis was the one that goes through the center in the short direction, and so this value here is b, and this value here is b as well. And each focus is c units from the center, and c is given by this formula here. C squared is a squared minus b squared. So we can label that distance c on here as well. Each one is c units from the center. So this distance is c. This distance is c. So we don't see the value c in the equation, but we find it using a and b, since c squared is a squared minus b squared. I mentioned that the closer each focus gets to the center, the closer it is to a circle, because a and b are getting very close. A circle is really just a special type of ellipse where a and b are the same value. So let's give an example. Let's say a and b are both 4. And let's just say the center is at the origin, just to make it easy. Then using that equation that we just saw for an ellipse, we're going to have x minus 0 for the center squared over a squared, 4 squared is 16, plus y minus k squared, k is 0 here since we're centered at the origin, over b squared, which is 16 again, equals 1. So that's using the ellipse formula. If we multiply both sides of this by 16, then we end up with x squared plus y squared equals 16, which we recognize as the equation of a circle. It's centered at the origin, and on the right side is r squared, so the radius is 4. So if a and b are the same value, you actually have a circle, and that value a or b is the length of the radius. So let's practice identifying these values a, b, and c, and then graphing an ellipse. So here the 36 is larger than the 9, so the 36 is a squared, and the 9 is b squared. Since the larger value is underneath the x, we know it's going to be longer in the horizontal direction. Since a squared is 36, a is 6. A and b are distances, so we don't have to worry about the fact that we could also square a negative number to get 36, because distance is not going to be negative. B squared is 9, so b is 3. And since the numerators will have x minus h squared and y minus k squared. H and k here are both 0, so the center is at the origin. So we can start graphing this. We can put our center there at the origin, and then this distance 6, we're going to go that distance from the center in the horizontal direction, the x direction, to plot each of the vertices. So we're going to have a vertex there and a vertex there. So that's the long direction, and then B is 3. So we're going to go from the center up 3 and down 3 to get the highest and the lowest points on the ellipse. And then we can just kind of draw it in the best we can. Mine is definitely not going to be that great. Then the only thing we didn't find is where are the foci. So we know that c squared is a squared minus b squared, and a squared was 36 and b squared was 9. So c squared is 27. So c is the square root of 27. Again, c is a distance, so we're not concerned with the negative square root. Square root of 27 is about 5.2, which kind of helps us graph where these foci are. We're going 5.2 units from the center along the major axis, the longer axis. So going out 5.2 units, it's going to put one of them about there and one of them about there. So they're pretty close to the vertices. I think it's helpful to graph it first, like plot the foci on there, and then write down the coordinates, because you can visually see I'm going from the center left and right along my major axis, and then you can see what plots did I point. One of them was square root of 27, comma 0, and the other one was negative square root of 27, comma 0. All right, this one does not look like our standard equations. Our standard equations have a 1 on the right side. And so if that's not the case, we're going to divide by whatever number is on the right side so that we can get that to be 1. And if we divide the right side by 144, we also have to divide the left side by 144. And since there's 2 terms there, we have to divide each term by 144. Then we can simplify those fractions. So 16 over 144 is 1/9. So we're going to have x squared over 9 there. And then 9 over 144 is 1 over 16. So we're going to have y squared over 16. Now this time the larger number is under the y part, so it's going to be longer in the vertical direction. So a squared is 16, which means a is 4. And then 9 is our b squared, so b is 3. The center is still 0, 0 because we have x minus 0 and y minus 0 upstairs. So there's our center. We're going 4 units in the y direction from the center, so 4 units up and 4 units down. There's our vertices. And then we're going to go 3 units in x direction from the center. So 3 units right from the center and 3 units left from the center. And then c squared is a squared minus b squared. So c squared is 7, and c then is the square root of 7. For graphing purposes, it's helpful to know that's about 2.6. So each focus is going to be 2.6 units from the center on the longer axis, which is vertical this time. So we're going to go 2.6 units up from the center and 2.6 units down from the center. So each focus has an x-coordinate of 0 since we didn't go left or right, and then the y-coordinates are square root of 7 and negative square root of 7. We're going to do a couple now where the center is not the origin. So here we have x plus 1. Now be careful because the formula says x minus h squared and y minus k squared, and the center is hk. So h and k are what's being subtracted. So here 2 is being subtracted from y, right? So we know our center is going to have a y coordinate of 2 because it's y minus k and it's y minus 2, so k is 2. This doesn't say x minus something, but it would be x minus negative 1, and so h is negative 1 for this one. So our center is at negative 1, 2. The larger denominator is under the x portion, so that's our a squared, and so a is 3. And then b squared is 4, so b is 2. Since the larger value is underneath x, it's going to be longer in the horizontal direction this time. Let's plot our center first. So the center is at negative 1, 2. So there's the center. And then we're going 3 units from the center in the x direction. So 1, 2, 3, 1, 2, 3. There's our vertices. And then we're going to go 2 units up and down in the y direction from the center. So up 2 units and down 2 units to get the highest and lowest points. And then we'll find our value of c. C squared is 9 minus 4. So c squared is 5, which means c is the square root of 5. And that's about 2.2. So we're going 2.2 units from the center in the long direction, so in the horizontal direction. So 1, 2, and a little bit. 1, 2, and a little bit. Now, if you're writing down the exact values of the coordinates for each focus, you're going to need to use the square root of 5 if you're writing down the exact value. And so it's a little more challenging when the center is not 0, 0, but we can work with that. We started at the center, which has an x value of negative 1. And the reason I'm looking at the x value is because we went left and right from that point. So we started at negative 1, and to get to this focus, we added that value c, right? That value c is the distance from the center to the focus. So we started at negative 1, and we added c to get to the focus on the right. So negative 1 plus square root of 5 is going to be the x-coordinate of this focus. The y-coordinate is 2 because we didn't go up or down from the center, and the center has a y value of 2. To plot the focus at the left, we started at the center, so starting again at an x value of -1, but this time we went to the left, so we subtracted that value c. So -1 minus the square root of 5 is the x-coordinate of that focus. And again, we didn't go up or down, so the y value is the same as the center. All right, for this one, the right side is not 1 again, so we need to divide by 16. Since we're doing that on the right, we have to divide every term on the left by 16 as well. Now for the first term, we have 16 over 16, which is 1. And then we have 4 over 16, which is 1/4. So when it comes to identifying the values of a and b, we're looking for those denominators. So you can think of this as being over 1. And now we can see that the y part has the larger denominator. So this ellipse is going to be longer in the vertical direction than the horizontal direction. So a squared is 4, and so a is 2. And then b squared is 1, so b is 1. And the center, this time, x minus h, we have x minus 1, so h is 1. And then y minus k, we have y minus -2, so the center is at 1, -2. So always plot the center first, since everything else is in relation to its distance from the center. So 1, -2 is our center. And then in the y direction, since this value came from the denominator under y, in the y direction we're going 2 units from the center. So 2 units up and 2 units down to plot our vertices. And then 1 unit in the x direction from the center. So 1 unit to the right and 1 unit to the left. And this is going to be very tough for me to draw since it's so tiny. And then let's find that value c. C squared is a squared minus b squared. So c is the square root of 3, which is about 1.7. Now the longer direction is the y direction this time. So we're going up and down from the center to plot each focus. So we're going about 1.7 units up from the center and about 1.7 units down from the center. So the points are going to have the same x value as the center this time. The center is at an x value of 1. So each focus has an x value of 1. But we went up and down to plot them this time. So we started at a y value of -2 at the center, and then we added 1.7 to get the top one, and we subtracted 1.7 to get the bottom one. But instead of 1.7, we should use the exact value, square root of 3. So -2 plus the square root of 3 and -2 minus the square root of 3 are the y values. This video is plenty long, so we're going to continue with a couple more graphing examples in a second video.